So to configure transducers, we start in the Configure Cube hardware plugin and select the transducers plugin here. Now immediately you can see that I have some transducers already configured. These physical transducers are displacement and load on my axial channel and angle and torque on my torsional channel. What I want to do is add an extensometer to the axial channel. So firstly I activate the transducer. Next step is to give it a use, and I want to use this extensometer for feedback. Now because there are two channels on this cube, I have to select which actuator I want to use it with, and I want to use it on the axial channel. Next is the choice of parameter, and I want to use this for extension control. And next is to set the full scale, and because it's an extension it's immediately set the units to millimeters. Well, I'm going to keep 100, but I'm going to make that microns. Of course this has to be the number relevant to your particular extension transducer. To do the rest of the configuration I use the left hand mouse on this config button, click, and now I get the extra configuration options. Polarity, if the transducer is wired back to front I can invert in software. Unipolar mode allows me to convert completely unipolar transducers into a bipolar signal for the cube processing. Transducer, this is asymmetric because it's going to allow me to zero this extension anywhere within its range, and conditioner type is DC, and I can have AC, so for an LVDT I can select this on the same input. Calibration, here's the excitation voltage and I can select that here. I'm going to stick with 10, but I can choose 10, 5 or 2.5 common values, or I can actually define a voltage if it's not a usual range. Down here I can, for an AC transducer, I can introduce some phase to allow me to get the best, highest millivolt signal out of the device. For the calibration I can choose, with the standard calibration I've got a single gain and then a fine trim value, or I can choose to enter, if I know it, the sensitivity of the device, and I can still apply some trim afterwards. I actually have the option of a 2-point calibration, so where I can apply a different positive and negative trim on the transducer, or I have the gold standard option, which is linearization. So in this case a single gain and trim I use to amplify my signal, and then I can actually put that through a table to remove any horrible nonlinearities. For now I'll stick with the standard calibration, and as you can see there's already some offset on this transducer, so if I undo that I can zero this transducer simply by selecting this button. This might drift because there's nothing plugged into this transducer at the moment. On the next tab, filter tab, I can use a digital filter, so it's implemented inside the controller. This filter can be low pass, can be anything from first to fourth order. I can use a low pass, a high pass, I can use a band pass filter, so I can actually define a range, or I can use this filter for removing particularly nasty frequencies. I'll stick with the low pass, and as you can see after a bit of filter processing the signal damps down with the noise now at 0.0064 without the filter. That's up at 0.043, so you can see the effect of the filter. Generally we don't need a filter, and of course if you're using a transducer for control you do need to be careful about aggressively filtering the signal, because you are reducing your control capability. And then finally on the last tab I can add information for the transducer, so I can put a serial number in. Also I can add notes, and down here I've that I borrowed this clip gauge from Mike Harris in civil engineering. When I do calibrate, I can enter a calibration date. So if I go for today's date, in fact I can select there and close. So that's my calibrated transducer, and as you can see I now have external as an option in my control loop. But I'm not going to use this extensometer directly, and what I'm actually going to do is use it to control strain, and to do that I can use one of our virtual transducers. When I activate that in the same way, I can use it as a feedback, and for the same reasons before I have to select which channel I want to control on and give it a parameter, and this is going to be strain feedback. And now the next thing I need to do is enter a formula. I just make that 100%. I want to enter a formula for this transducer, so I need to be able to identify the extensometer. So I'm going to go back to transducers and I'm going to check this checkbox down here, and I'm going to add a symbol E for extension, and I can add symbols for any of these if I want to use them inside a virtual transducer. And then back to the virtual transducer page, left hand click on the config button, and here I can type in my formula using standard mathematics. So E, what this transducer now is a copy of my extension, but I'm going to multiply it by a constant value which I'm going to make up, and this number would typically be the area of the specimen under test. Now in our test systems we do allow you to enter this number dynamically, but if you want to do it manually, this is how you do it. So now I have strain feedback, and if I apply pressure, it's actually possible for me to go into strain control or extension control. When I take pressure off, then you'll see that the control always reverts to setup mode. And that's the end of the demo.